In this video, I want to talk about solving a word problem using a quadratic equation with rational roots. So let's go ahead and try to figure out what this problem is talking about. So it says the length of a rectangle is 4 yards less than 3 times the width. Okay, so let's actually go ahead and write that out. So the length is equal to 4 yards less, so that's going to be minus 4, then 3 times the width. So 3w, right? 3 times the width minus 4 is 4 yards less, right? 4 yards less than 3 times the width. Okay, that's what the length is. And the area of the rectangle is 55 yards squared. So the area of a rectangle is equal to length times width, right? Okay, so we want to find the dimensions of the rectangle. So what I'd like to do is I'd like to take this area equation and substitute what we know to be the length for the length in here. So we know that the length is equal to 3w minus 4. Okay, so now we have the area as all a function of w. So let's go ahead and multiply this out. So we get area equals 3w squared minus 4w. Okay, very good. So now I want to go back and look at what is the area equal to, and it tells us that the area is 55 yards squared, right? So 55 is the area. So we can put that into our equation and we'll get 55 is equal to 3w squared minus 4w. Okay, now we want to solve this. So in order to solve a quadratic equation, the first thing that we need to do is get it equal to 0. So a quadratic equation must be equal to 0 in order to do anything else with it. So I'm going to subtract 55 from both sides. And then we'll get 3w squared minus 4w minus 55 is equal to 0. Okay, now there's a couple of different ways that we might factor this, but I want to go ahead and just sort of do undo FOIL. This is a little bit trickier than some because we know that it has to have a 3 in front of one of these. So one of these needs to be 3w, right? And one of them needs to be w. So that's a little bit trickier than if it's just 1, but we can do it. Now, 55, we need to think about what multiplies to 55. So the two numbers that I'm thinking of are 5 and 11. So 5 and 11 multiply to be 55. So the way that I would recommend doing it is just go ahead and put it in. So let's put in 11 here and 5 here. We might need to change this, not sure yet. So let's think about what we have here though. So inside here would give me 11w, and the outside here would give me 15w. Now, I know from this that one of them should be positive and one of them should be negative, and that actually seems like it'll work because like a 15 minus 11 is 4. So now we just need to make sure that the 15 is negative and the 11 is positive so that we get a negative 4. So to make the 15 negative, we need to have a negative 5. And to make the 11 positive, we have the positive 11. And this way, when we do our outer and our inner, the outer is going to be negative 15w, and the inner is going to be 11w, and that will give me negative 4w. Okay, so that works. So now I can set each of these independently equal to 0. So 3w plus 11 equals 0, or w minus, w minus 5 is equal to 0. Okay, so w equals 5, or 3w equals negative 11, which means that w equals, oops, I can't see that. So w equals negative 11 thirds. Okay, so now my question is, can the width of a rectangle be equal to negative 11 thirds? So the fraction's not a problem, but the negative is, right? The width, a rectangle can't have a negative width. So this does not actually work in the context of the problem. So the width needs to be 5. Now, to figure out, they asked for the dimensions of the rectangle. So to figure out the dimensions, we also need the length. So I can go back here and it says length equals 3 times w, which is 5, minus 4. So 3 times 5 is 15, minus 4 is 11. So the length of this rectangle is 11 yards, and the width is 5 yards. And that's how the area gets to be 55. So this is my answer. And that's how we solve a word problem using a quadratic equation with rational roots.